We're going to talk about the domain of a rational function and then vertical asymptotes. So we have a rational function here. A rational function is anytime we have a polynomial over a polynomial. Now, what we need to be concerned about is the fact that we can possibly get a 0 in the denominator. So in looking at the domain, what we're going to do is we're going to take the denominator and set it equal to 0. In this case, we have a quadratic. So when we have quadratic equal to 0, we can see if it'll factor. If it doesn't, we can use the quadratic formula. In this case, it'll factor. This one factors into x plus 2 times x plus 3. So we can rewrite our function as x plus 2 over x plus 2 times x plus 3. And probably noticing, hey, we can cancel these x plus 2's. We can. We're not going to do it, but I am going to talk about the significance of those in a second. Now, these came from looking for the zeros. So the places where it's 0 is x equals negative 2 and x equals negative 3. So we don't want to include those in our domain. So let's put lines through those. So we would write up our domain in interval notation as negative infinity to negative 2, parenthesis because we don't want to include it, union negative 2 to, we should be going to negative 3 first. We always want to do this in order, negative 3 to negative 2, and then union negative 2 to positive infinity. So there's our domain. Now, a lot of times when we have something that makes a 0 in the denominator, it creates what's called a vertical asymptote. So what that means is we have a place where the graph kind of blows up. And you can take a look at that with your graphing calculator. Right now we're just talking about how to find them. So we have possible vertical asymptotes at negative 3 and negative 2. The reason I say possible is because we have something interesting going on at negative 2. If you have a number that makes a 0 in both the denominator and the numerator that's of the same multiplicity, that means it's repeated the same number of times, then what we have is what we call a whole. So there's actually not a vertical asymptote at negative 2. There will be one at negative 3. So the equation for the vertical asymptote is x equals negative 3. So we have a vertical asymptote at negative 3, and we're actually going to have a whole. So we know it's at negative 2 for the x value. The whole is actually, we could actually find a y value because it's actually a single point that's been removed from our graph. The way we would find this is we actually would cancel out those x plus 2's, and we'd get 1 over x plus 3. These are almost the exact same functions. The only difference is negative 2 is in the domain of this function, it's not in the domain of ours, which is why I'm not using equals. So if I were to plug negative 2 in for x, I'd get 1 over negative 2 plus 3, or 1 over 1, or 1. So we have a whole at x equals negative 2, or at the point negative 2, 1. So that's how we can find the domain of a rational function, write it up in interval notation, identify the vertical asymptote, and also look to see if there's a whole.